Hello, this video is to help you with geometric sequences. Now, a geometric sequence is very similar to an arithmetic sequence. So you'll notice over here at the left, we've got a sequence that goes from 3 to 9 to 15 to 21. This is an arithmetic sequence. Again, not what this video covers, but more than likely, if you're looking to learn about geometric sequences, you've probably already learned about arithmetic ones. Arithmetic sequences are a common difference between numbers. So notice we're adding 6 each time. So we often set up what looks like a linear equation, a sub n equals the fact that we're going to go up 6 per step that we take, but occasionally starting from a different number. So I backed up from 3 minus 6, that would be a negative 3. And now if I wanted to find any one term, such as number 21 here, that's our fourth term, a sub 4 plugged in would be 6 times 4 is 24, plus that negative 3, and it would get us right back to the 21, again, we were looking for. So this would be a good arithmetic, again, sorry about the handwriting there, but arithmetic sequence. Now, notice that the sequence on the right does not have a common difference. 36 minus 12 is 24, but 108 minus 36 is definitely much more than 24. So that wouldn't work out too well for us. However, if we look carefully, 12 times 3 would get us 36, and 36 times 3 would be 108. So just like we would normally do for an arithmetic sequence, really to find our common difference, we actually normally take one term minus its previous to get us that difference of 6. Well, if we're going to multiply over and over, why don't we just take any term, so 36, and divide by its previous term? And we'll get what's called the common ratio. Okay? And that comes out to a 3. As we noticed, we're multiplying by 3 each time to go forward, or essentially any term divided by its previous would be our common ratio. Well, if that's the case, instead of adding 6 every time, we want to multiply by 3 every time. So we could say that a sub n is equal to any term times 3. Now that's a very recursive formula to realize that we're going to multiply by 3 and then multiply by 3, but we're just doing it from term to term to term. If we want to do multiplication over and over and over again, usually we try to use an exponent. So if we took 3 to a power, right, or the power of n, what I'm saying is 3 to the first would be 3, 3 to the second would have been 9, and we're kind of getting those new terms. Again, 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, and so forth and so on. Now there is one slight problem with that, in that we don't want 3 and 9 and 27. We want 12 and 36 and 108. But 3 times 4 is 12. And 9 times 4 is 36. And 27 times 4 is 108. Or basically, if I took each of my steps times 4, I should be able to get the sequence that we have up top here. That's a geometric sequence. And again, that's what this video is meant to help you with. A geometric sequence is one that has a common ratio. Any term, a sub n plus 1, divided by its previous term, right, term n, so again, n plus 1 comes one term after n. Any term divided by its previous term gives you that common ratio. And the nth term formula for that is basically if we start from the first term, or we have an initial place to begin, we can multiply that times the common ratio raised to the nth power. Now, because we're starting on step 1, very similar to an arithmetic series, if we're already on step 1, but we want to get to step n, well, if you are on the first step of a staircase, I don't need to take n steps. I need to take n minus 1 steps. I've already taken the first step. So again, this is sort of a mix of an nth term formula along with sort of a recursive formula. It's taking you from one step to whatever future step you want to get. So notice up top here, if we're asked to find the first 5 terms of the sequence, we could first set up the formula, but really if we already know a sub 1, The basic idea is I want to take that term and I want to multiply it by my common ratio. I'm going to take any term times my ratio to get to the next term. And again, any term times my ratio to get to my next term. So 35 times 5 would have been 150 is 175, I do believe. And now I'd want to take 175 times 5. And you'll notice very quickly that geometric sequences get very large very fast. So that just became 875. And now I want to take 875 times 5. And just by the fifth step, we're already at 4,375. That's a pretty big number. So to get to the 20th step, well, I don't want to keep on recursively multiplying by 5 over and over and over and over again. That's a lot of steps, and I fully expect that to be a really large number. Let's go ahead and set up our sequence. So again, the basic formula is take a sub 1, so that's 7, times our common ratio. Notice we're going up by multiples of 5, raised to the n minus 1, because again, 7 was already step 1, steps. Or in order to get to the 20th step, I'm going to start at the first step. I'm going to multiply by 5. 20 minus 1, or 19, times. 20 minus 1, or 19. Sorry about the handwriting there. I'm going to try to make that 9 look a little better. There we go. Times. And again, I fully expect that to be a very large number, because 5 to the 19th is already 1.907 times 10 to the 13th power. Then I'm going to multiply that by 7, and really I end up in scientific notation as 1.335, we'll let the rest of it go, times 10 to the 14th power. So a very large number. A very large number. Geometric sequences, again, are very similar to an exponential function. They grow very, very quickly. Now, if they're not just asking us to find term by term by term or set up the basic formula, what if they want us to find a specific term but given terms at the bottom? Again, that's a very common question with sequences. So, similar to an arithmetic sequence, let's take advantage of our formula over here at the left, and let's fill in what we know. I know that I have a sub 2 is 3, and I know I have another term, a sub 5, my fifth term, is 3 over 64. Now the one downside is I'm looking for a sub 1, so my formula over here, where I know a sub 1 is kind of plugged in, isn't really going to be very helpful. But if we adjust the formula, we can really start at any step we want. Let's call it a sub x. So I'm going to start at term a sub 2, since that's the one that I know. And then I'm going to try to pursue, I'm going to try to go to step a sub 5. Because again, it's also a term I know. I should be able to plug those in here in a minute. What I don't know is the common ratio, but I can raise that to the n, which again over here would have been the step I'm already on, minus 2. Right? Or basically, in order to get from step 2 to step 5, I need to multiply by r 3 times. So let's plug in what we know. 3 over 64 is equal to 3 r to the third. We'll divide by 3 on both sides, which essentially is multiplying by 1/3. So let's go over here. Basically, that's going to cancel my 3's, so I'm going to be 1/64 is equal to r to the third. And to get rid of a third power, we take a third root. So the third root of 1/64, again, third root of 1 is 1, and the third root of 64 equal to r right now is technically 1/4. So now we have our ratio. Well, to go find a sub 1 then, all I need to do is start at any term, so we'll call it a sub 2, multiply by our ratio, 1/4, which explains why things were getting smaller, not larger, raised to the, again, 1, where we want to be, minus 2, where we already are. Plug in what we know. A sub 2 was 3 times 1/4 raised to the negative 1, which basically is 3 times the reciprocal, or times 4, and a sub 1 should be equal to 12, which kind of makes sense. Again, if we're multiplying by 1/4, 1/4 of 12 would have been 3, times a fourth, times a fourth, times a fourth would have been 3/64. We're getting all the correct terms. Again, I hope that helps you with geometric sequences. If you have any questions about that, feel free to rewatch the video, or just go ask your teacher some questions. I'm sure they'd be happy to help you walk through a few more problems. Happy practicing, happy multiplying, and have a great day.